The air isn't breathable. The ground beneath you radiates heat that would liquefy lead. In the distance, clouds rain sulfuric acid. This isn't a nightmare. This is what standing on another world would actually feel like. And your body, evolved for one specific planet, wouldn't survive the experience. Today, we're exploring a purely hypothetical scenario based on planetary science and human physiology. What would actually happen to the human body if it were somehow transported to the surface of each planet in our solar system? No spacecraft, no protection, just the raw physics of 8 alien worlds and how they would interact with human biology. This is entirely theoretical, grounded in what we know about atmospheric pressure, temperature extremes, and the limits of human survival. Let's begin with the closest planet to the Sun, Mercury. On the day side of this world, surface temperatures reach 430 degrees Celsius, hot enough to melt zinc. But you wouldn't feel the heat gradually. Within seconds, the side of your body facing the sun would begin to burn. The ultraviolet radiation, unfiltered by any atmosphere, would simultaneously cook exposed skin at the cellular level. But here's the paradox. Mercury has almost no atmosphere. That means no air pressure. Your body, accustomed to Earth's atmospheric pressure of 101 kilopascals, would immediately begin to respond. The moisture on your eyes and tongue would boil away first, not from heat, but from the vacuum. At 0 atmospheric pressure, water boils at any temperature. Within 15 seconds, you would lose consciousness, not from heat, but from hypoxia. With no oxygen and no air pressure to keep your blood oxygenated, your brain would begin to shut down. The extreme temperature differential, frozen shadows mere meters away from scorching sunlight, would create thermal shock across your body. At the 30-second mark, your body would exhibit what's called ebulism, the formation of water vapor bubbles in bodily fluids. Your tissues would begin to swell. Scientifically speaking, this would be the point of no return. Even if rescue were hypothetically possible, the cellular damage would be catastrophic. Venus. The atmosphere here is 92 times denser than Earth's. That means, hypothetically, the moment you arrived, you would feel the equivalent weight of being 900 meters underwater on every square centimeter of your body. But pressure is only the beginning. The atmospheric temperature sits at 465 degrees Celsius, maintained by a runaway greenhouse effect. Your first breath, involuntary as your body would gasp for air, would sear your respiratory tract instantly. The sulfuric acid vapor suspended in the clouds would begin corroding exposed skin within seconds. Within 10 seconds, the heat would penetrate beyond the skin. Your blood would begin to approach coagulation temperature. The pressure would compress your chest cavity, making that second breath physically impossible. Your body's internal fluids, unable to expand or cool, would begin to destabilize. At 15 seconds, unconsciousness would be inevitable. The human brain cannot function above 41 degrees Celsius for extended periods. Here, your core temperature would be climbing past 50 degrees within the first minute. Hypothetically, this environment represents the most hostile surface in our solar system for human biology. The combination of crushing pressure, extreme heat, and corrosive atmosphere would act simultaneously, leaving no biological system intact. Mars. This world feels deceptively familiar. Temperatures can reach 20 degrees Celsius near the equator during summer. But the atmospheric pressure is less than 1% of Earth's, about the same as standing at 35,000 meters altitude. Your first challenge would be immediate. The air is 95% carbon dioxide. Your lungs would fill with a gas that cannot sustain human life. But unlike the vacuum of Mercury, there's just enough pressure here to prevent immediate boiling of bodily fluids. Within 10 seconds, you would begin experiencing hypoxia. Your vision would narrow, Extremities would start to feel cold, not from Mars's temperature, but from your body prioritizing oxygen to vital organs. At 30 seconds, confusion would set in as your brain begins oxygen starvation. The low pressure would cause the moisture in your airways to evaporate rapidly, creating an intense sensation of dryness. By 90 seconds, you would lose consciousness. But here's what makes Mars scientifically unique. This is the only planet besides Earth where your body wouldn't be destroyed instantly. You would simply asphyxiate, the way a climber might at extreme altitude. Death would occur within 2 to 3 minutes, but your body would remain physically intact. The point of no return here isn't marked by physical destruction. It's marked by the 3-minute threshold where brain death becomes irreversible. Jupiter. There is no surface here. This is a gas giant, a planet made of hydrogen and helium with a possible solid core buried beneath thousands of kilometers of supercritical fluid. Hypothetically, if you could somehow be placed in Jupiter's upper atmosphere, you would immediately begin falling. The gravity here is 24.79 meters per second squared, 2.5 times Earth's. Your body would feel more than twice its normal weight instantly. But gravity is only one force at work. As you fell deeper into the atmosphere, pressure would increase exponentially. At the depth where pressure reaches 1 atmosphere, roughly equivalent to Earth's surface, the temperature would already be minus 100 degrees Celsius. Within 30 seconds of falling, you would descend into layers where pressure climbs to 10 atmospheres, then 50, then hundreds. Your chest cavity would compress. The air in your lungs would be forced out by external pressure. At this depth, you would still be falling at terminal velocity, accelerating into increasingly dense layers of hydrogen. At 90 seconds, you would reach depths where pressure exceeds 1,000 atmospheres and temperatures climb above 150 degrees Celsius. At this point, the distinction between gas and liquid becomes meaningless. You would be surrounded by supercritical fluid, matter that behaves as both gas and liquid simultaneously. The point of no return on Jupiter isn't a specific moment. It's the instant you begin falling. In this environment, there is no stable position, no surface to stand on. Only descent into increasing pressure and heat until the human body would be compressed beyond recognition. Saturn. Similar to Jupiter, this world has no solid surface, but Saturn's atmosphere presents a slightly different profile. Lower gravity at 10.44 meters per second squared, and a colder upper atmosphere. Hypothetically, as you fell through Saturn's cloud layers, you would first encounter temperatures of minus 180 degrees Celsius. At this temperature, exposed skin would develop frostbite within seconds. But you wouldn't remain at this level long. The fall would take you deeper, past layers of ammonia ice crystals, through zones where pressure climbs from 1 atmosphere to 10, then to hundreds. At around 50 seconds of descent, you would cross the threshold where atmospheric density makes breathing mechanically impossible, even if there were oxygen. By 2 minutes, you would be at depths where pressure exceeds several hundred atmospheres and temperatures have climbed back above freezing. Your body would be subjected to forces equivalent to the deepest ocean trenches on Earth, except continuing to intensify. The scientific reality of Saturn is that it represents a gradual transition from frozen upper clouds to superheated depths. Your body would experience the full spectrum: flash freezing, then gradual compression, then heat stress, all while falling continuously deeper. Uranus and Neptune. These ice giants present similar environments, frigid upper atmospheres hovering around minus 200 degrees Celsius, composed primarily of hydrogen, helium, and methane. At these temperatures, exposed tissue would freeze solid in under 10 seconds. The methane in the atmosphere would prevent any oxygen exchange, even if you could somehow breathe. But like the gas giants, you would be falling. As pressure increased with depth, temperatures would paradoxically rise. Within 90 seconds, you would descend to depths where the ices of these planets, water, methane, and ammonia, exist as hot, compressed fluids under thousands of atmospheres of pressure. The point of no return on these worlds occurs within the first 10 seconds, when surface tissue freezing becomes irreversible. But the complete dissolution of human biology would take minutes, occurring gradually as you fell through increasingly extreme conditions. 8 worlds. 8 different ways the human body, adapted for one specific set of conditions, would fail when confronted with alien physics. These scenarios aren't designed to disturb. They're designed to illustrate something profound: how incredibly precise the conditions for human life actually are. Temperature, pressure, atmospheric composition, every variable must fall within a narrow range. We exist in a universe of extremes, and our biology, remarkable as it is, was built for only one tiny corner of it.